Hello, we are Team EcoSorters dealing with the problem of separating clean cardboard from contaminated specimens.
This is the team. We're working with Mark Wallach at the Golisino Institute for Sustainability to create a recyclables sorting robot.
So the problem we're trying to solve is we want to have a robot that can have 90% accuracy in sorting samples. It can be used within a 5 by 5 by 0.01 inch sample size up to a maximum of 8 by 11 by half inch. It should be able to inspect many samples in 1 minute. It should automate the inspection process without any human intervention and be able to maneuver safely.
Currently, recycling facilities sort out recyclable materials by having a worker grab it out of the moving conveyor belt using their naked eye. This is putting undue stress on landfills because a lot of what gets thrown out could be recycled. This prototype will prove the feasibility of a robotic sorter, which will more effectively and accurately sort out clean versus dirty cardboard and paper materials.
So, as this prototype is a scaled down design compared to real recycling facilities, we also had to scale our approach. We chose a sample size that is at most the size of a standard piece of paper to keep the system contained to a workbench environment. Given our budget and time constraints, we decided to make zones, the input where the samples will be placed down, and the drop offs, which represent the contaminated versus non contaminated. In practice, these zones would really be conveyor belts where the input conveyor belt brings the sample closer to the robot, and then when the robot sorts the sample, that will be carried away to either be recycled or discarded.
Our proposed solution is the High Wonder robot. This is a robot that has 4 degrees of freedom to pick up samples and rotate. The robot has a suction cup intake that is connected to an air pump. This design was picked because it is efficient in moving samples and can easily be scaled up by increasing the robot and the air pump size to handle larger materials.
For the final build, safety was a large concern, as this would be a large machine in a real world environment. A safety barrier was put in place and an emergency stop button was attached to the robot. The e-stop halts all movement within half a second and is available to press outside of the safety barrier. An electrical box was also made to hold all electrical connections to limit accidental contact. The robot can move about 27 samples per minute into the center of the correct zone.
We would like to thank our client, Mark Wallach, for taking the time to meet with us over the past year and helping us understand the real world application of our design. We would also like to thank Dr. Tiona McCauley for her help in navigating the MSD phases to get a holistic and well documented project.